Trust me, within 10 years, that dividend is going to be almost zero if you reduce it by 20% every year. What is D1 I need to pay? And we can solve that. It's not terribly difficult. Remember, if value is supposed to be price now, which is 62 and a half, right? So in this case, we can actually calculate this. It says, did you say 5% for the growth? Yes. Come on. But I want my template to find that number for me without me doing any calculation. I can also solve this problem using the DGM template in solver mode, green light, by making market price equal to 62 and a half and the unknown or the solve for dividend number one. I mean, in this case, obviously, I don't need that machinery to find the answer. I mean, this is like using an AR-15 to kill a little rabbit instead of a birdshot. But if all you have is AR-15, that's what you're going to use, right? Or in fact, it's more like using a 50 cal machine gun. It's that powerful. Problem is simple, but it still kills the rabbit. You can probably eat it, but the rabbit is dead as it is. All right. First things first, I'm going to change my input to dividend amount number one, because that's what I do not know. My market price is 62.50. Required rate of return is that. That's 5. That, I don't know that one. All I have to do is make this green light. Double click, solved it for you. It's different from the answer I got because this is only 2 digits. In fact, I'm gonna make this whole thing 3 digits. Let's make it 4 digits. I don't have to, but so anytime you know the result of the valuation calculation, but you don't know what are the inputs, you have to be in solver mode. Remember, we did the same thing when we were finding either the coupon rate or yield to maturity in bond valuation. We knew the value of the bond, we just did not know one of the inputs. That's what gave you that value. Same thing here. Now let's make a more interesting calculation. Suppose, let's go back to, oh, not this one. You have some discount rate. The stock is trading at 62.5. I know the first five dividends, 1, 2, 250, 3, and 325. And after that, it's going to grow at 5%. What discount rate is going to give me that 62.5? That problem is actually does not have an algebraic solution, which means I cannot write it in terms of simple function. It has a solution. You cannot write it in terms of algebraic functions. Basically, here's the equation you're solving. Um, I'm going to go ahead and write it in long form. Even if there was an algebraic solution, it was going to take a lot of time to do the algebra, right? Now I need that 50 cal machine gun. Simple. What's my inputs? Number of known dividends is 5. Right now it's solving for dividend 1, but I'll worry about that. In fact, let me change the unknown to required rate of return. That's 5%. 5, 1, 2, 250, 3, 325. Done. See that pink one? As soon as I change the input and it does the solve, it changed the color of the unknown to pink. So 911 actually takes care of that. If you want a little bit more precision, that never hurts. Actually, the number was 91057. Now you know the power of this. Or I could have asked simple thing like, I'm giving you the discount rate. What second stage growth rate would have given you this? Suppose I'm doing that. I mean, right now it's going to tell you 5 because it's consistent with that. Suppose I go back to my 12%. If the growth required rate of return was 12, at what growth rate, given this first 5 dividends, you will get a value of 6250. Done. I mean, you can solve for G2 algebraically. It requires a little bit of careful manipulation of the equation. But again, why do you have to? Remember, math is the problem. Math is the art of reducing the problems to things you know how to do. You know how to use this template in solver mode. Choose your unknown, enter the other inputs, enter the final value, done. Because every time I change one of the inputs and or the output, the goal seek in the background is triggered. It actually finds that input that gives you the value of that output you want. That's why I built this. Again, this is not limited to this problem. Remember, we use this for bond valuation. In chapter 8, we're going to do something called, for example, modified internal rate of return or crossover rates and that sort of stuff. They are also goal seek type problems. All I have to do is do it for the known inputs, put it in solver mode, choose my unknown, give the output I desire, you're home. You do project evaluation, you want to find your uh, break even level of price given your sales projections in numbers. Assume you knew the price, set up your equation for your profits, then find the price that's going to give you exactly zero net present value. Done. Mathematically speaking, they're identical problems. In topology, we call them isomorphic or homeomorphic. I got about 5 minutes. Maybe I'll keep you guys 5 more. I want to talk about 2 more things in chapter 7. One is a preferred stock. You can also read this in the chapter, but the value of the preferred stock is the dividend divided by R, because the preferred stock pays a constant dividend every year, okay? Or every quarter, then the quarter would be, the annual number would be 4 times that quarterly. This is sometimes also known as a perpetuity. But for legal purposes, the preferred stock is not a debt instrument. And here's why that matters. It matters, A, because of tax. If you had a bond, let's say this was a 200-year bond, practically a perpetual bond, right? Any interest payments you make on that are tax deductible. Firm pays $100 on that, you can deduct that off your taxable income. In the preferred stock, no. For legal purposes, it is considered stock.